This is part 3 of section 8.4. Just like we did with simple interest, you often want to figure out what you need to invest today to end up at a certain goal. So we have the present value formula for compound interest. If you'll notice, all it is, this is the future value. All of these two are, this is our new formula, but all it is this formula solved for P instead of A. So it's not magic, it's just rearranged. So what we're going to do is we're going to be solving some problems for this, trying to figure out our present value. And just like in the simple interest section, we are going to round up just to make sure that we do end up with enough money so that we are not short even a little bit. Okay, so first problem. How much money should be deposited today in an account that earns 7% compounded semi-annually so that it will accumulate to $12,000 in 4 years? So I'm going to pull out our information here. Our rate is 7%, which we're going to write as 0.07. Semi-annually, so our N value is 2. Our accumulated value is 12,000. And our time is 4 years. Now, if we plug into this formula, the principal is $12,000 divided by 1 plus our rate, 0.07 over N, which is 2, raised to the N times T, so that's 2 times 4 power. So I'm going to simplify inside those parentheses some. I have 0.07 divided by 2 plus 1. So my present value is 12,000 divided by 1.035 raised to the 2 times 4 is 8. So to calculate this, I have 12,000 over, I'm going to open parentheses, 1.035 and raise that part to the 8th power. And I get just over $9,112. I'm supposed to round up, always to the nearest, round up on these problems. So I need to deposit $9,112.94 today in order to make sure that I have that much money in 4 years. I will be slightly short if I had rounded this to 93 cents. Okay. How much money should be deposited today in an account that earns, not years, earns 10.5% compounded monthly so that it will accumulate to $22,000 in 4 years? Okay, so our rate is 10.5%, which is 0.105. Compounded monthly, so our N value is 12. Our accumulated value should be 22,000. And time is 4 years. So present value is the accumulated value over, so 22,000 over 1 plus R over N, so 0.105 over 12, raised to the N times T, 12 times 4. Extend that fraction bar just so that it's perfectly clear. And this is equal to, that's going to be 48. Okay, so there are a couple ways you can do this in your calculator. You don't want to write down and use an estimate. You want to keep everything in your calculator as long as possible. Now I can enter this if I'm super careful. I can enter it directly as it is. So this would be, I'm creating a fraction, $22,000 over, open parentheses, 1 plus 0.105 over 12, close parentheses, making sure the parentheses is still under the fraction bar. And then I'm going to raise that to, I can enter 12 times 4 here if I want to, but I'm just going to go ahead and do 48. And I get my answer. That I should deposit $14,000, 14,481 and 47 cents because we have to round up. Okay. Now, if you want to do this in multiple steps, there are a couple of tricks you can use. Let's say I want to figure out what's inside this parentheses first. 0.105 divided by 12. Now, add 1. And then raise that to the 48th power. And this is our denominator. Okay. Now, I want to divide 22 by this number. Now, I don't want to write this down. There are a couple of things you can do. You can put it into memory. On these calculators, you hit STO for store. It says answer arrow. And then right here is your variable button. And I hit X. And then what's going to happen now is if I just hit X, it's going to bring the same number back up. So I can calculate 22,000 divided by X. And I get the same value I did here. Now another, if you don't want to use your memory, our key is going to be right, where is this one? It's above this one, 1 over, there's a box, and your button may look like x to the minus 1. So it'll look like that, or maybe like this. That's going to be the key button we're going to use. It allows us to divide out of order. So if I figure out this bottom, doing the same calculations we did earlier, and then raising that to the 48th power. Now I'm going to do bottom divided by top, which is dividing out of order. And then I hit that button. On this calculator, I'm going to have to hit second and then that. And it's going to give me, it basically allows you to divide out of order, and this just flips it back. And I get the same value. But you definitely want to keep everything in your calculator as long as possible. If you write down and use a decimal approximation, you're introducing an error into the problem that can really blow up if you keep using an inexact number.